Hello everyone, welcome to our lesson today on linear regression. We're on 15.3 for today. So regression, unlike correlation, requires an explanatory or a response variable. We talked about how the explanatory variable is always on the x-axis, so this x right here is the explanatory variable. And then the y, this is called y hat with that triangle type figure on the top, that's called y hat. And this is the response variable. Okay, and so with linear regression, linear means a line, so a scatter plot that generally resembles a line. We can use the linear regression line to make predictions about what might happen with the data. And so it's written in this form. It's actually written in several different forms. You can see how A in this case is the y-intercept. You've heard of the equation many times before, y equals mx plus b. So the one that's all by itself, this b over here, that's the y-intercept. In this equation, the a is the one that's all by itself. It's going to be the y-intercept. The slope is always multiplied by x. So this bx over here, the b is the slope. You're used to seeing m as slope. So that's what it is in algebra. In statistics, it actually can go by a couple different letters. This is also an equation that you might see sometimes. Y hat equals ax plus b. Well, if that's the case, now b is the y-intercept and a is the slope. Basically, what you got to remember is that whatever letter is multiplied by x, that's the slope. If it's mx plus b, m is the slope. If it's bx, then b is the slope. If it's ax, then a is the slope. So whatever one is multiplied by x is the slope. So because these always deal with explanatory and response variables, let's again just have a little more practice trying to understand what the explanatory and response variable is in relationship to this data. How does drinking beer affect the level of alcohol in our blood? The legal limit for drinking in all states is a 0.08%. In a study, adult volunteers drank a different number of cans of beer, and 30 minutes later, a police officer measured their blood alcohol levels. So what would be the explanatory variable? What is the cause? The cause is the alcohol, or the number of cans of beer. Number of cans of beer. So the explanatory variable, what is it having an effect on? What's the response variable, what is it having an effect on? What is the effect? We want to measure their blood alcohol level. Blood alcohol level in the blood. So the alcohol that they're consuming is the cause. The alcohol level in the blood is the effect. Okay, let's try another one. The National Student Loan Survey provides data on the amount of debt for recent college graduates, their current income, and how stressed they feel about college debt. A sociologist looks at the data with the goal of using the debt and income to explain the stress caused by college debt. So if you look at this one, the explanatory variable, it almost kind of says right here, they want to see how debt and income can explain stress as a result of student debt. And so the explanatory variable, what's causing is the debt and income. Amount of debt and income. So then the response variable would be the stress that they feel. The stress caused by college debt. So we see these explanatory and response variables. Here's the explanatory variable, here's the response variable, and if they generally have a linear relationship, we can make a linear regression line, and that's what we're going to define next. A linear regression line, it goes by a couple different names. It goes by the linear regression line, the least squares regression line. And another name it can go by is the line of best fit. Different stats teachers use all three of those for the same thing. And here's what the linear regression line is. a line that describes how response variable changes in relation to an explanatory variable. It's only used for linear data. If there's a quadratic or if it's an exponential type of a graph, we don't use the linear square regression line, the least square regression line, or the line of best fit. We only use it for linear data. It's only used when there's a cause and effect relationship. Okay, so when something has a cause on the other variable, that's when we use the linear regression line. It's strongly affected by outliers. You've seen that correlation is affected by outliers. The mean is affected by outliers. The linear regression line also affected severely by outliers. One thing that's great with this is we can use it to make predictions. That's why we have the y hat. It's a predicted value. We don't necessarily expect it to be right on, but it's going to be close to it. It's a predicted value. We only make it within the limits of the data, and you'll be seeing that in the video lesson here for today. And then at best model, the linear regression line works best if it closely fits the data. So if it's a strong relationship, if a correlation coefficient is close to 1, that's when the least square regression line works the best. So let's try to practice some things with this now. We're going to draw the least square regression line, or draw the linear regression line. We're going to draw the line of best fit. So the line of best fit, or the linear regression line, is a line that we can best represent our data. So basically try to draw a line that goes right through the heart of your data, right through the middle of your scatter plot. So here is, I'm going to start with this one over here because it's the strongest association. So I'm going to draw a line right there. Try as best you can to have the same amount of data entries that are above your line as there are below your line. A line that goes right through the heart of your data. So right here would be the linear regression line. As best you can, try to have it go right through the middle of your data. Here's our linear regression line for this one. Here's our linear regression line for this one. The weaker the relationship, the more difficult it is to draw that linear regression line, because people can make arguments all over the place. Some might say, Mr. Berge, there is the least square regression line. And one person might say, no, I think this one is. And another person might say, I think this one is. So it can be kind of difficult if it's not a very strong relationship. So just make sure that you're aware of that. I wouldn't give you ones like this one or this one on a test, but just for the sake of practicing, let's have our least square regression line be right there, and we'll go right here. Basically, the linear regression line is a line that best represents the data. Okay? So, when we draw what we just did with these 6, we are humans, we make errors all the time, we just can't do things perfectly. Our graphing calculator is perfect at finding regression lines. What it does is it makes the sum of all the squares of the vertical distances of the data from the line as small as possible. So there might be all these little data entry points, and it kind of averages all of those distance so that it completely puts it right in the middle of all of your data. That's what your calculator is doing, and we're going to practice that with our calculators today. So I want you guys to put this into your graphing calculators, put it into, and actually class, I put my data into list 3 and list 4. So feel free to put into list 1, list 2 if you want to, but if you want to put into list 3, list 4 like I did, that would be just fine as well. So here's all of our schools. Here's the percent attendance that they had. One might make the argument that the better attendance you have, the better GPA you're going to have. The more days you miss school, the lower your GPA might be. That's a very logical possibility. So what we're going to do here, we enter this into our graphing calculator. Let's make a scatter plot. So let's practice this. If you haven't entered the data into your calculator, please do that at this time. So we press Stat, and then Edit, and under list 1, or sorry, under list 3 and under list 4, I have entered in my data. Okay, so now we're going to make a scatter plot with our calculator. So whenever we graph something in this class, you press second y equals. So there's all of our plots. We'll do plot 1. I have mine on a histogram right now. Let's move it to our scatter plot, which is the very first one. So right now my cursor is blinking over that first one. I'm going to press enter, and there's my scatter plot. Okay, for my X list, for my explanatory variable, that's going to be my attendance. I put that data into list 3. So second 3 is my attendance. GPA is my Y variable, it's my response variable, so I'm going to put L4 and I'm good to go there. So now I press second mode to get right back to my original screen, and then I press zoom 9. And zoom 9 makes my scatter plot. So there it is. So why don't you guys pause the video and try to put this on your graph paper in your notes that I gave you. After you did that, you should have got something that looks like this. Make sure you label your x-axis and your y-axis and title your graph. This would be like the attendance and GPA at various schools. And there is my scatter plot roughly. Okay, you can just kind of estimate it. Describe the form, direction, and strength of the relationship. We are on this bullet point right now. So basically describe the DOFs of the graph. Well, you could say, I would say this is a pretty strong relationship. It's linear. It's a positive, so there's a strong positive linear relationship between the attendance that students attend school and the GPA that they earn. Are there any outliers? I would say that it would be hard to make a case for outliers on this one. There's no data that's way off compared to the rest. So draw in the line of best fit. So if I were to draw the least square regression line or the linear regression line or the line of best fit, best representation that goes right through the heart of the data might be something that looks like this. Something like that. Okay? So you guys could do that. Now what we're going to do is we're going to have our calculator do that work for us. Our calculator is going to draw in the least square regression line or the line of best fit. So here's how we do that. I'll teach you how to do that right now. When you go to your calculator, you press Stat. Now go over to Calculate and go down to number 4, this linear regression. That's what we want to find. We want to find the linear regression line, and we're going to have AX plus B. So that means A is going to be the slope because it's multiplied by X. B is going to be our y-intercept. Okay? So we press number 4. Again, we got to tell our calculator what list we want. Oftentimes we put data into list 1, list 2. This time we put the explanatory variable into list 3, and we put the response variable into list 4. So I enter and I calculate, and here is my A value. My A value, my slope, round to 4 decimal places, is a 0.0379. My B value is a negative 1.3710. So that's how you calculate, you see the correlation coefficient is right here. The way you graph linear regression, there's your slope and y-intercept right there. So we're going to write that right over here. What is the linear regression line? We're going to put y hat, which y hat is our predicted value. So y hat, that equals AX plus B. So our A value is 0.0379 times X plus B. So minus 1.3710. So that's our linear regression line. And it's not a bad idea here either to put it in the relationship with our data. Stats all the time uses our data. So our Y variable, our response variable, is GPA. So the predicted GPA, or GPA hat, that equals 0.0379 multiplied by the percent attendance. Attendance is the explanatory variable. So we oftentimes use those instead of X's and Y's. We're going to use our actual attendance. So the beauty of the linear regression line is now I can use this to make predictions. What would we expect the GPA to be if a school had 77% attendance? Well, the GPA, or GPA hat, the predicted value, is equal to 0.0379 times the attendance, and this time the attendance is 77%, minus 1.3710. So if we put 0.0379 times 77 in our calculator and subtract 1.3710, we would get roughly a GPA of 1.55. We can do the same thing. How about if that was 91% attendance? Wouldn't we expect the GPA to be a little bit higher? Well, GPA, the predicted value, is equal to 0.0379 times 91 minus 1.3710. Put that in our calculator, 0.0379 times 91 minus 1.3710, and that GPA we would expect to be a 2.08. So we just predicted the Y values, or the GPA, but now we can use the GPA to predict, I wonder what the percent attendance would be. So we could put 2.15 into GPA right here. That equals 0.0379 times the attendance, that's what we want to find, minus 1.3710. So we could simply add 1.3710 to both sides, and then at the end divide by 0.0379, and we would get the percent attendance, roughly 93%. So now take a look at this next one. If the GPA was 3.30, what would we expect the attendance to be? So 3.30 we'd put in on the left side of the equation. That equals 0.0379 multiplied by the attendance, that's what we want to find, minus 1.3710. If you get this, you would get 123%. Class, is there anything, is it possible that we can go to school 123% of the days? That is impossible. Perfect attendance is 100% attendance. There's no way of getting 123%. This is called extrapolation, everybody. Extrapolation is using the regression line the way it's not intended to be used. We can only make predictions inside the limits of our data, and a GPA of 3.3 is outside the limits of our data. So extrapolation is using the regression line for a prediction far outside the interval of our values. These predictions are often not accurate, and we should not use them. We shouldn't make predictions outside the limits of our data. Okay? So only within the limits of our data. If we do it outside, it's called extrapolation. Let me know if you have any questions when you get to class tomorrow.